Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on parameters. Earlier on, I have done this ABCD parameters. On the part 1 series discussion, I simply define what is ABCD parameters. This video, I'm going to give you two examples of ABCD parameters. I'm going to show it to you how can we actually find the overall ABCD of a cascaded. Okay, for example, okay, you have various components that are cascaded together, and basically this video, I'm going to show it to you how can we actually make use of ABCD parameters in order to calculate the overall ABCD parameters. This will be the part 2 series discussion on ABCD parameters. So guys, if you're keen to know more about parameters such as S parameters, Z parameters, and also Y parameters, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on parameters. This is my email. If you have any question regards on this discussion, please drop me an email. Before I continue, I'd like to ask you guys to help me by like this video so that this video can reach to a larger audience. Guys, if you are new to this channel, please consider to subscribe to this channel. Or maybe later on, when you realize that you learned something from this video, please again consider to subscribe. Please also on your notification bell so that in future, you will be able to receive information regards on this channel. Guys, once again, thank you so much for strong support. Okay, so let's understand quickly what is actually a ABCD parameters. Okay, so these ABCD parameters are just a very simple set of equations. They actually give a relationship between input voltage and current versus the output voltage and current. In short, if you take a look on this equation and also in this diagram here, okay, for this diagram, you can see that all the input is on your left, okay, all the output is on your right. We have the voltage, okay, the input voltage, the input current, the output voltage, and you can see that they are actually related by ABCD parameters. Like the diagram, the ABCD actually sit in between the input and output. So over here, you can see that this ABCD parameters is sitting on the input and also the output. Okay, you can see over here, okay, basically the V1 and I1 is actually so-called dependable variables, while V2 and I2 are independent variables. And from this metric, you can easily derive this set of equation. So next, okay, I actually put two so-called two separate components. They can be a completely different component. Basically, they are cascade together or in parallel together. Okay, so how can we find the overall ABCD parameters? For example, this set is the first ABCD parameters for this so-called particular component, as you can see from this ABCD parameters. This will be the second set of ABCD parameters. Okay, for the second device, for example, as you can see that this will be the ABCD for the second device. In order to calculate the overall, as you can see here, this is V1, I1, okay, which is here, and the final one is V3, I3, which is on your right-hand side. You can see that I simply combine the 2x2 matrix together. The first one will be from the first set of ABCD. The second one will be from the second set of ABCD. And when I actually do this, I actually combine the effect of these two things that are actually cascade together. So now let's take a close look. How can we actually combine this 2x2 matrix? Okay, so this is what I have shown it to you on the previous page. Okay, so if you still remember this in your mathematics, basically I will say that will be these two lines here. Okay, you can see that, for example, if I want to, the 2x2 matrix, for example, okay, the outcome will be in fact another 2x2 matrix. So you can see that this is also another 2x2 matrix. So how can I get this so-called the first item, okay, of the 2x2 matrix? I will use A1 multiplied by A2 plus B1 multiplied by C2. Okay, as you can see from here. So as indicated by the arrow, I will use this to multiply plus this multiply by this. I will get the first component. So next, how can I actually find this component, okay, of the 2 by 2 matrix? Again, you can imagine the line draw here and versus here. So what I can find is C1 multiplied by A2, as you can see from here, and then plus D1 multiplied by C2, as you can see from here. As for the third component at the 2 by 2 matrix here, again, you can see that instead here, it will be here. So it will be A1 multiplied by B2, as you can see from here, plus B1 multiplied by D2. And last but not least, will be C1 multiplied by B2, and then D1 multiplied by D2. Okay, so basically, this will give me the overall ABCD parameters of these two items, can be completely different two items cascade together. So now, okay, let's work up a very simple example. Okay, so earlier on, I have shown some of the ABCD parameters for some of the two-port network. Okay, so now I will briefly explain how can we actually find the ABCD parameters, okay, of this two-port network consists of a series impedance Z between port 1 and port 2. So over here, you can see that this Z is in fact between port 1, which is the input, and port 2 will be the output. Okay, so earlier on, I have derived this ABCD parameters equation here. So now, for example, if I want to concentrate on A, how to find A? So A will be here. So in order to find A, I need to meet I2 equals to 0. So once I meet I2 equals to 0, I can easily find A by moving this V2 over, will be V1 over V2 as illustrated over here. Okay, do you agree? So basically, this is how I can find the A parameters of the ABCD. Simply, first thing, I need I2 equals to 0. Once I meet this I2 equals to 0, this whole thing disappeared. I just need to shift V2 over. So A will be equals to V1 over V2. Okay, so this will be uniqueness as voltage divided by voltage. So therefore, you don't have any unit. So how can we achieve this I2 equals to 0? Okay, so we need to do an open circuit at the output. So once I have this open circuit at the output, my I2 will be automatically become 0. Okay, so how can I continue this? Okay, imagine this Z here as a resistor. Just imagine there's a resistor here to meet, so-called analyze this easier. There will be a resistor here. So what happened here is basically when there's a resistor here, okay, I can actually determine from this situation here, I2 is equal to 0. So therefore, I conclude that V1 is equal to V2. Okay, because there is no I2, and when there's no I2, I can conclude that V1 is equal to V2. So therefore, A is equal to 1 because A is equal to V1 over V2. And since these two things are equal, so therefore A is equal to 1. Okay, so this is the first ABCD parameters A, okay, which is equals to 1 when actually a series impedance is connected between port 1 and port 2. Okay, so now let's move on to B, how to find B. Okay, so B, okay, if I want to find B, okay, I need to make this term equal to 0, which means that I need to make B2 equals to 0. And once I make B2 equal to 0, okay, I can easily find B by shifting this I2 over. It will be V1 over I2. Okay, so over here you can see that basically V over I will be described a unit by ohms. Okay, so basically B will be ohms. So next, okay, how can I actually make V2 equals to 0? So if I want to make V2 equals to 0, I need to do a short circuit. When I actually has a short circuit, which means that a wire is actually connected over here, there won't be any voltage drop. Okay, ideally, there won't be any voltage drop. So V2 is equal to 0. So therefore, I need to short circuit at the output so that I can achieve V2 equals to 0. Okay, so guys, again, imagine that there will be a resistor value here. Okay, how can I find I2, for example? What will be my I2 value? I have my V1 divided by Z. I will be able to find my I2, correct? So basically, it's illustrated over here. Okay, so how to find my I2? I will have my input voltage. I have my impedance. Basically, I take my input voltage divided by my impedance. I should be able to find I2. Okay, over here, I1 supposed to be the same with I2 also. So over here, since I have this V1 and I have this I2 described as V1 over Z, and if you rearrange the formula, okay, you will find out that the B term is equals to Z. Okay, which means that the B term is actually having the same value of the impedance. Okay, so basically this will be the B term of the ABCD parameters. So now let's move on to C. Okay, so how can I actually find the C term? Okay, in order to find the C term, I need to make this I2 equals to 0 again. So if I make the I2 equal to 0, this whole item disappeared. So how to find C will be simply moving this V2 over, will be I1 over V2. And this is called a Siemens, or the opposite of ohms. So basically, this is how I can find the C term. Again, okay, you will probably ask, how can I actually make I2 equals to 0? Okay, in order to make I2 equals to 0, I need to do an open circuit at the output. When I do an open circuit at the output, current will not be able to flow, and therefore my I2 is equals to 0. Okay, remember I told you that imagine there will be a resistor here. So if I2 equals to 0, I can also assume that I1 will be equal to 0, because anything enter will be anything that will be at the outcome. If the outcome is 0, therefore no current supposed to be entered into the impedance. So therefore, from here, I conclude that I2 and I1 is equal to 0. And from here, if this is 0, 0 divided by V2, the C will become 0. And third ABCD parameter C, which I have found out for this so-called series impedance Z in between port 1 and port 2, okay, the C term will be equals to 0. So now let's move on to D. Okay, so D is actually called a short circuit reverse current transfer ratio. Let's understand how can we actually find this. Okay, now the objective is to find D. So in order to find D, I need to make this V2 equals to 0. Okay, so once I make this V2 equals to 0, this whole thing disappeared. So how to find D will be I1 over I2 as illustrated over here. Okay, this will not have any unit because it's current over current, so it's uniqueness. And how can I actually also make this V2 equals to 0? I basically need to do a short circuit. Once I do a short circuit, my V2 will be equals to 0 as illustrated here. Okay, so I need to do a short circuit at the output in order to achieve V2 equals to 0. So once this is short circuit, again, imagine there is a resistor inside the Z. Okay, whatever flow in current will be whatever will be flowing up. Okay, so therefore I1 is equals to I2. And again, these two current is identical. So therefore I conclude that the D will be equals to 1. Okay, so I have found the last ABCD parameters, which is D, which is equals to 1 when I actually have a series impedance Z in between the input and output port. Okay, so in fact, you can use this to find all the so-called earlier on discussion on the two-port network, all the so-called examples. Okay, you can also understand by doing this kind of derivation. Okay, so next, let me do the example number 2. Okay, so before I do the example number 2, okay, the usefulness of the ABCD matrix representations lies in the fact that the library of ABCD matrix for elementary two-port network can be built out and applied in building block fashion, okay, to more complicated microwave networks that consist of cascade of these similar two-port. Maybe let me digest this for you. Okay, if we use this ABCD matrix, basically it's much more favorable because every simple so-called ABCD matrix can use to describe a two-port network. Okay, we have various ABCD to describe a two-port network. And when they are actually cascade together, we can easily find the overall ABCD parameters. So guys, again, if you find this video helpful, please help me to like this video and consider to subscribe to this channel. Also, guys, remember notification bell, okay, is important so that in the future, you will be able to see something similar like this form of discussion. So guys, please help this channel by doing all this now. Thank you so much. Let's move on to the example 2. Okay, so example 2 will show a real scenario of work here. Okay, so this, for example, this example 2 show you 3 items here. So this is a transmission line. Okay, so basically this will be a middleware that is connected in between the two transmission lines. So this is one term of ABCD. This will be the second pair of ABCD, and this is the third pair of ABCD. Okay, so the key usage of ABCD parameters is I can easily find the overall. For example, let's say I have the S parameters for this guy, S parameter for this guy, and S parameter for this guy. I may have big issue to find the overall S parameters. However, with ABCD, okay, for example, I have the ABCD parameters, okay, for this transmission line, which is governed by this equation, which I have shown you on a part 1 series discussion on the ABCD. Okay, so basically, I will be able to know first part, ABCD parameters. Second part of the ABCD parameters is also shown it over here. Okay, so basically, all these common ABCD parameters, okay, device, etc. Okay, I actually have list up the table on the previous discussion, on the first part 1 series discussion on ABCD. Okay, I can also easily find my second so-called ABCD matrix. And then the last part of the so-called the device will be another transmission line. So this will be another ABCD parameters to describe this transmission line. So in short, you can see that these three items are all connected together. I can easily find the overall, okay, which is the overall effect of ABCD by simply multiply the 2 by 2 matrix together. So instead by word, let me show it to you. How can we actually make this possible? As I mentioned earlier on, this pair of ABCD is used to describe a transmission line. Okay, this set of ABCD is used to describe, okay, this kind of configurations. And the third part here, this will be the third set of ABCD, again, is used to describe a transmission line. Okay, in order to make the discussion easier, okay, more fruitful, okay, let's assume that the transmission line is quarter wavelength or 90 degree. Okay, so once I punch 90 degree cosine 90, I will get 0. Okay, if sine 90 is equal to 1, so therefore I get this J Z naught. And again, this sine 90 will be equal to 1, and therefore I have J Y naught over here. And cosine 90 will be 0. So basically, I just make use of this ABCD to reduce the complexity of this 2 by 2 matrix here. It will be the same for the third set of ABCD. So you can see that these two sets are exactly the same. So now what I need to do in order to find my final ABCD, I will use this first set of ABCD, multiply by the second set of ABCD, and then finally multiply by the third set of ABCD. Then I will be able to find the overall set of ABCD. Okay, so basically this is how I do, as I mentioned earlier on, the final total ABCD parameters of the whole circuit, okay, this whole circuit. How to find the total ABCD basically will be the first set of ABCD multiplied by the second set of ABCD multiplied by the third set of ABCD. I always like to do it step by step. So basically you can see here, this is the first set of ABCD. This will be the second set of ABCD. Okay, so how does the first set of ABCD look like? Okay, so basically earlier on, I have shown you this will be the first set of ABCD. Okay, basically they are here. This will be the second set of ABCD, okay, which is over here. So therefore, I use these two combined together. I get the two combined effect of ABCD of the first and the second. Okay, 0 multiplied by 1, J plus JZ naught multiplied by Y naught here. So basically from here, 0 will be 0. This thing multiplied together, I will have J1. Okay, again, from here to here, okay, 1 multiplied by JY naught, 0, everything will become 0. That's how I get JY naught here. Okay, and then I do this versus here. So 0, 0, nothing. So 1 multiply, I get JZ naught here. So the last one will be here versus here. So this one multiplied by 0, this one multiplied by 0. Therefore, this will be the outcome. Okay, so basically this will be the outcome of the first ABCD multiplied with the second ABCD. And I use this, I put it here, I multiply by the third ABCD here. So again, it will be in this kind of format. So this multiplied by 0 will go to 0. Okay, J multiplied by J, okay, I will get a minus. Okay, I think I have a typo mistake. It should be supposed to be -1 here. So sorry. Okay, so this part here, please take note, this will be a -1. I have a typo mistake. J multiplied by J, okay, which is equal to minus So therefore, I supposed to have -1 here. Okay, I have a typo mistake. This is supposed to be minus J1. Okay, so again from here, okay, versus here, we'll get this term here. So J times J will be minus, okay, will be minus Z0 here. So this will be minus J0 without the J term. Okay, so this multiply by 0, and this will be 0 here. Okay, and then J multiplied by J will be minus. So this is supposed to be -1, and this will be 0. Okay, I made a mistake here. Okay, remember there won't be any J term. So this will be -1 minus Z0, 0, and -1. So this will be the overall effect of the ABCD for the whole effect of these three things that connected together. Okay, again, I have made some mistake. Okay, so therefore, okay, so this is how we can find the overall ABCD parameters. Okay, guys, I'm sorry. Please take note of the mistake that I made over here. Okay, so with this, I'd like to end my discussion. Please help to like and subscribe. Once again, thank you so much for strong support. Okay, I hope to see you guys soon. Bye for now.